Hello, everybody, and welcome to lesson 4.8 about logarithmic differentiation. So this is going to give us a method to take derivatives of things that otherwise look complicated to take derivatives of. So let's get cooking talking about logarithmic differentiation. So typically we're going to use logarithmic differentiation when we have an equation that has a variable located in the exponent, or if we have some kind of equation that can be simplified, not simplified using the properties of logarithms. So we're going to take a look at some ways we can do this, but first we want to quickly review the properties of logarithms. So these are the properties of logarithms in case you have forgotten them. Log base a of a to the x is x. I'm not going to bother you reading through all of them. If you need them, pause the video and write them down. But we're going to use them to quickly expand this logarithm. So what we can do here is this division means we can write this as two separate logarithms. So this is ln of 2x minus 4 to the third minus ln of 9x plus 1. And then we can apply this power rule right here, and we can rewrite this as 3 ln of 2x minus 4 minus ln of 9x plus 1. So this is now an expanded form, and when it comes to taking derivatives, it's going to be much easier to take the derivative of this than it would be to take the derivative of this. So now let's take a look at a couple examples where we would use logarithmic differentiation. So let's say that I have y equals x to the x, and I want to take the derivative of this. So the problem is if I tried to take the derivative of this using normal methods, we don't have a rule that we can use for this. So what we can do is we can rewrite this as ln of y equals x times ln of x. We took ln of both sides of the equation, ln of x to the x, we can apply the power rule, and this is x times ln of x. Well, when I say power rule, I mean the power inside of a logarithm rule. That means we can multiply by the power. So now if I take the derivative, this would be y prime over y, because this is 1 over y times y prime because of the chain rule, equals, if I want to take 1d2, so this is going to be x over x because it's x times 1 over x, plus 2d1, so that's ln of x. So now I can solve for y prime, and y prime, remember, is dy over dx. So y prime would be y times 1 plus ln of x. Now, luckily, I know what y is equal to. Y is equal to x to the x. So then dy over dx, y prime, would be equal to x to the x times 1 plus ln of x. So this would be the derivative of this function. And we were able to accomplish that using logarithmic differentiation. Basically, I took the logarithm first, and then I differentiated. So let's take a look at one more example. So let's say that I have y equals 3 times x minus 4 to the x plus 2. So again, I have a variable in the exponent. So let's try and use logarithms to simplify this a little bit. So if I take ln of y, if I simplify this side using logarithm rules, this would be ln of 3 plus x plus 2 times ln of x minus 4. Now here, if I take the derivative, again, ln of y, the derivative of that is 1 over y times y prime. So this would be y prime over y. The derivative of this term is 0, so now I just use the product rule here. So this would be x plus 2 times 1 over x minus 4, which is just x plus 2 over x minus 4, plus that's 1d2 plus 2, ln of x minus 4 times the derivative of this first term is just 1. So then here, I can say y prime equals y times x plus 2 over x minus 4 plus ln of x minus 4. And now again, I know what y is actually equal to. So now y prime, which is dy over dx, is equal to 3 times x minus 4 to the x plus 2 times x plus 2 over x minus 4 plus ln of x minus 4. So we've now found the derivative of the function thanks to logarithmic differentiation. So that is it for today. We're going to do more examples of this in class, but today we talked about logarithmic differentiation, when to use it, and then also just a review of expanding logarithms that will be useful when doing this kind of logarithmic differentiation. So I hope you took some good notes. I hope you come to class ready to learn, and I hope you have a fantastic day. I will see you in the next unit.